Okay, AP Statistics fans, our topic for today, this is Note 6-3, Binomial Experiments. Now, this is an introduction to the section. This is not going to be the whole section. It's kind of a review if you've seen this in pre-calculus or Algebra 2. So the goal after this lesson, students should be able to use the binomial theorem to calculate probabilities. Before we begin, let me give you your joke of the day. What is a cat's favorite treat in the summer? And the answer is a mice cream cone. All right, so we're going to start with the idea of flipping a coin where we have two possible outcomes. We have heads and we have tails. Now, if we flip a coin one time, what are the possible outcomes? Well, you could get heads or you could get tails. Now, I'm going to write this and say that we have one way to get one heads and we have one way to get 0 heads. I will do this in terms of heads. Now, if we flip a coin twice, what are the possible outcomes? Well, we could get heads, 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 tails, tails, heads, tails, tails. So in this case, there is one way to get 2 heads. Now to get 1 heads, we could get heads, tails, or tails, heads. So there are 2 ways to get 1 heads, and then there is 1 way to get 0 heads. All right, we'll do this one more time. If we flip the coin 3 times, what are the possible outcomes? So let's see, we could get H, H, H. We could get H, H, T. We could get H, T, H. We could get T, H, H. We could get H, T, T. We could get T, H, T. We could get T, T, H. Or we could get tails, tails, tails. 1, 2, 3, 4, 5, 6, 7. Okay, so there's a total of 8 possible outcomes. Now, to get all heads, there's only one way to do that. So one way to get 3 heads, we can get 2 heads, 1 heads, or 0. Now, to get 2 heads, we're looking for HH. 1, 2, 3. So 3 ways to do that. To get 1 heads would be HTT, THT, TTH. So there's 3 ways, 1, 2, 3 that I circled. 3 ways to get 1 heads, and then to get no heads means we get all tails. There's 1 way to do that. So a couple things are happening here. We can talk about probability. The probability that we get 3 heads, well, there's 1 way to get that out of 8 possible outcomes, so that would be 0.125. The probability that we get 2 heads is 3 out of 8, which is 0.375. The probability that we get 1 heads is also, there are 3 ways to get that out of 8 possible outcomes. So that's also 0.375. And then to get no heads, there is 1 way out of 8, which is 0.125. Now this is a valid probability model because we have all 4 of these probabilities would add up to 1. Okay, so again, we always have to have all the outcomes add to 1. Now, the reason why we work this out is that when you start looking at numbers here, there's a little pattern that comes up. If you look at the number of ways of doing this, 1, 1, 1, 2, 1, 1, 3, 3, 1, and this is a famous pattern called Pascal's triangle. And Pascal's triangle looks something like this on the side, 1, 1, 1. And to get the next row of numbers, what we do is we add the 2 numbers directly above. So 1 plus 1 is 2, that's 1. So it always starts with 1. 1 and 2 is 3, 2 and 1 is 3, and then it ends in 1. So notice that 1, 3, 3, 1 is the same thing we get from flipping a coin 3 times. If we kept going, this would be 1, 4, 6, 4, 1, and I'll go one more time. 1, add these up, that's 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then this is 1. Okay, so Pascal's triangle, if we were to flip the coin 4 times, there's 1 way to get all heads, 4 heads. There's 4 ways to get 3 heads, 6 ways to get 2, 4 ways to get 1, and 1 way to get 0. But what happens is that if we wanted to flip the coin, say, 10 times, then this is going to start becoming a little bit burdensome because we'd have to write this out over and over and over. Okay, so there's another pattern that's going to come up here. These values are combinations. This would be 5 objects chosen 5 at a time. This would be 5 objects chosen 4 at a time. This would be 5 choose 3, 5 choose 2, 5 choose 1, 5 choose 0. Okay, now what that means, these are combinations. If you've studied combinations and permutations. Now, if you haven't studied this, then I have a separate set of notes that talks about combination permutation. But on the calculator to show you, I can calculate combination permutation. For example, if I do 5 choose 3. So I go 5 and then math. I go over to probability, PRB, and notice that number 3 says NCR. That means combination. So out of 5 objects, I'm going to choose 3 of them, and I get, there's the number 10. If I do 5 choose 4, just to show you, I should get a value of 5. Yes. So I can come up with these values by using my knowledge of combinations. Now, if I wanted to flip the coin 10 times, and, okay, so let's say we flip 10 times, and we want to get 4 heads. How many ways can we do that? Well, it would be, the combination is 10, choose 4. Now the actual formula for finding a combination is 10 factorial divided by 4 factorial times 10 minus 4 factorial. Now that's if you wanted to work it by hand, but again, I'm going to use the calculator. 10, math. So we're going to do a combination. So how many ways could I flip 4 heads? And the answer is 210. Okay, so obviously I don't want to be having to write out all of these possibilities here. So let's do an example here of what we call a binomial experiment. And I'll talk about what that means in a second, how we actually know that something's binomial or not. So let's say we flip the coin 5 times. Now we've already said, we've written down, here's the row for 5 flips. So in terms of, you might say, well, wait a minute, that's the 6th row. But the first number at the top is for 0 flips. 1, 2, 3, 4, and 5. Okay? So these are going to be the number of ways that we can get this done. You flip a coin 5 times. So what's the probability that we get 4 heads? Well, one thing that we want to understand is we can have success or we can have failure. In this case, the probability of success is 0.5. Success will be we get heads. Failure will be we get not heads, or in this case, tails. Well, the probability of failure, the probability that we flip a coin, assuming this is a fair coin, it's 0.5 and it's 0.5. So these are the same. And one thing to know, I'm going to write this, the probability of success plus the probability of failure raised to the n. N is the number of times or the number of trials that we are going to use. And in this case, we always have to have the probability of success and failure has to add up to 1. And it does, because it's 0.5 plus 0.5. So the probability that we get 4 heads, the first number here is, let's see, 4 heads. So that's right here. It's going to be 5. Whoops, sorry. It's going to be 5. And it's heads raised to the 4th times tails raised to the 1st for that. So we've got, whoops, sorry. We're going to flip 5 times, so this is how I'm thinking about it. And if we get, so 5 times h raised to the 4th, 4 heads and 1 tails. And there's going to be 5 ways to do that. Well, the probability of heads is 0.5. And the probability of tails is 0.5. And then what we do is we multiply. So 5, let me clear that up, 5 times 0.5 raised to the 4th times 0.5 raised to the 1st equals 0.15625. So this would be the probability that we get exactly 4 heads. Out of 5 times, we're going to flip 5 times. That's the number of trials. And this is the probability of 4 heads. Probability of 4 heads. All right, now what if we want to know the probability that we get at least 4 heads? Well, that would be the same as the probability of 4 heads, or the probability that we get 5 heads. So at least 4 means it could be 4 or it could be 5. Okay, so we're going to make 2 calculations here. Now we already know the probability of 4 heads was 0.15625. The probability of 5 heads, that we get all heads, if I go back to Pascal's triangle, there's one way that we can get, this is 5 heads, 4, 3, 2, 1, 0. So there's one way to get 5 heads. And then it's 0.5 raised to the 5th, and then 0.5 raised to the 0 for that. Okay, so if we calculate that, so really it's just 0.5 raised to the 5th power, we get 0.03125. And then what we're going to do is we're going to add that to the probability that we get 4 heads, and what we get is 0.1875. So that is the probability of at least 4 heads. All right, so let's say we want to do the probability of at least 1 tails. Now that could be 1 tail, 2 tails, 3 tails, 4 tails, or 5 tails. So that would be the probability of 1 tail plus the probability we could get 2 tails, we could get 3 tails, we could get 4 tails, or we could get 5 tails. Now the problem with this, obviously you're seeing this is starting to get fairly long. Okay, so we can do this 5 times and we can add those up. Or we can subtract anything left over. Remember that all the probabilities have to add up to 1. So the probability of at least 1 tails is every possible outcome except 0 tails. So if we can find the probability that we get 0 tails and subtract that from 1, then everything left over is going to be these values. Now the probability of 0 tails, well, that means we get all heads. That's the probability that we get 5 heads. Now we calculated in the last part of this that the probability of 5 heads is 0.03125. So it's 1 minus 0.03125. And if we subtract that from 1, we get 0.96875. So 0.96875. And that's the probability that we get at least one tail when we flip the coin. So if we flip it 5 times, there's almost a 97% probability, that we're going to get at least one tail. And that is the end of part 1.